This is Tier 3 Lesson 9, completing the square. Now we can finally complete the square fully, because now we have when a is not equal to 1. So remember we did that b divided by 2 squared to complete it? Well, before we do that, we're going to factor out our a term. So this 3, we're going to divide out our GCF. So we're going to divide this 3 out of only these first two terms. So we get 3x squared plus 4x. And then we have minus 16. So what we're going to do is that b divided by 2 squared thing that we've been doing before. So I'm going to take my 4 divided by 2 equals 2, and I'm going to square it and get 4. So I'm going to add 4 to complete the square. Well, remember, if I add 4, I need to subtract 4. But this minus 4, I don't want in my parentheses. So to get it out of my parentheses, I'm going to multiply it by that 3, that a. So I'm going to get x squared plus 4x plus 4, that's my completed square. And then I have minus 12, right? That 3 times negative 4 took it outside. Minus 16 equals 0. So I'm going to factor my completed square, so I get 3x plus 2 squared, right? Remember, it's one of those perfect ones. You could check me if you don't believe me. And then minus 28 equals 0. Now to solve it, I'm going to add 28 to both sides. And then I'm going to divide by 3. (28) divided by 3 does not work out perfectly. Then I'm going to take my square root of both sides, plus or minus. So then I get x plus 2 equals plus or minus square root of 28 over 3, and I'm not even going to bother with that. Then we subtract 2 from both sides. So we have two answers. We have plus and minus square root of 28 over 3 minus 2. Maybe I could do more with that, but for now, that's fine. Hopefully they don't get as bad in your practice. But now we can officially convert any of these into vertex form, right? And this is where that negative b over 2a comes from, because we have to divide our first two terms by that a. So I'm going to divide out that 2 and bring it in front. Now I'm going to complete the square with my 6 divided by 2. Gives me 3. And then I'm going to square it. So I'm going to add 9. Okay, which means I need to subtract 9. Now remember, I need to multiply this 2 times negative 9 to get it out of those parentheses. So this is and 2 times negative 9 is negative 18 plus 1. Now I can factor this perfect square polynomial. So I get 2x plus 3 squared minus 17, right? If I say x squared, we get x squared. 3 times 3 is 9, and then 3x and 3x will give us 6x. You can check it with that Punnett square. But now I got my vertex of negative 3, negative 17 if I wanted that. And that wasn't that bad. So what if I had this? Well, here's proving that negative b over 2a very quickly. I'm going to divide a out of my first two terms. Okay, and then when I complete the square, I take b divided by a, and I divide it by 2. Well, when I divide it by 2, that makes it b over 2a. And that's what I would complete the square with. Okay, and then I would subtract. I would do that other stuff. I'm not going to worry about that other junk. But when I would factor this, I would get ax plus b over 2a squared, and then some other junk. But when I have my vertex, I know my vertex has negative b over 2, and that's where it comes from, and then I would have my y value where I plug it in, and I could show you that as well, but I'm not going to.